The AFIA MQP aims to increase accessibility of robotics in sub-Saharan Africa. We worked with engineering students at Academic City College University in Accra, Ghana, to determine what were the biggest challenges facing robotics in the region. It was determined that the biggest challenge was the import cost associated with common robot materials like metal. Shown in the table are the primary goals of the AFIA MQP. The goals were designed specifically for robotic operation in the target region, though no part of the project involves actually sending a robot to Ghana. In order to traverse the roads of Ghana, our robot will need to overcome obstacles like non-traditional speed bumps and fallen trees while avoiding people on the roads. In order for the robot to be able to safely travel on these roads, it will need to know what it can go over and what it cannot. I have Red Rover-style rocker to accomplish these tasks. The differencing bar pushes one side of the rocker down when the other rocker side is pulled up. To ensure we met our longevity goals, our robot is made primarily of wood and PVC, with metal only where absolutely necessary. The proposed design calls for teak, which is readily available in Ghana, but hard to get in Worcester, so our prototype is made from plywood and oak. Performing full system testing, we tested individual components in the lab space. The first system tested was the differencing arm and rocker. As you can see, the design is capable of distributing motion across the two rocker legs. Tested the augmented autonomy and teleoperation controls. Shown here is an example of our obstacle avoidance system. If you direct your attention to the motors, you will see that the student moves in front of the robot into the range of the ultrasonic sensors. The motor operation ceases. In order to override the sensor, the student must toggle the controls horizontally and then is able to resume motor function.
During our driveline testing, we discovered the connection between our rocker and our box was highly inefficient. This led to uneven load distribution, which caused motor brownout. This was corrected by replacing our shoulder bolt connections with a solid steel axle and reinforcing the pivot point with an aluminum bracket. While it is possible to make an all-terrain robot out of alternative materials like wood and PVC, it is not possible to make it entirely out of those materials. Metal is required at critical points to ensure its solid connection. Even with some imported materials, robots like AFIA still have the potential to expand accessibility of robots. We would like to thank everyone who has assisted us with this project, specifically our wonderful advisors, Professor Ken Stafford and Brad Miller, the staff of the Washburn Machine Shop, Squad, the students from Academic City, and Professor Pradeep Radhakrishnan. We would also like to thank our families and friends for their support. Finally, thank you all so much for your time today.